Okay, before we fully define machine learning and predictive analytics, let's start out with a couple stories about presidential elections and forecasting. In this video, I'll cover 2 ways forecasting is often misunderstood. Correcting these misconceptions comes down to the fundamental idea of what a probability is. Then in the next video, I'll tell a related political election story that beautifully illustrates the difference between forecasting and predictive analytics. So, when it's a presidential election year in the United States, speculation is in the cards. It's the national pastime. Everyone wants to predict who'll win. But man, did people mismanage their own expectations leading up to the 2016 presidential election when Donald Trump defeated Hillary Clinton. There seemed to be more surprise than when you shake hands with one of those electric shock gags. This was due in no small part to the misinterpretation of election forecasts. In 2016, it looked like this. Nate Silver's forecast put about 70% odds on Clinton winning. Who's Nate? Well, there's no better known person of prediction in this country, no more famous prognostic quant than former New York Times blogger and political poll aggregator Nate Silver, who had gained notoriety at the time for correctly predicting the outcome of the 2012 presidential election for each individual state. In the US, each state's majority vote usually determines its overall vote as a state. When Clinton lost in 2016, everyone was like, OMG, epic fail. The reasoning was, well, the 70% forecast that she would win had proven to be wrong, so the problem must have been either bad data, the polls were way off, or something about Nate's model, or both. But, the forecast wasn't bad. 70% does not mean Clinton will clearly win, and a 30% chance of Trump winning isn't a long shot at all. Something that happens 30% of the time is really pretty common and normal, and that's what a probability is. It means that in a situation just like this, it'll happen 30 out of 100 times. That is 3 out of 10 times. Those aren't long odds. And Clinton's 70% probability is actually closer to a 50-50 toss-up than it is to a 100% sure thing. When you see 70%, the takeaway isn't that Clinton is pretty much a shoo-in. No, the takeaway is, I don't know, lots of uncertainty. Now, I believe many people saw that 70% and the thought process was sort of like, well, 70% is a passing grade, so Clinton will definitely pass, so Clinton will definitely win. But prediction is hard. To be more specific, there are many situations where the outcome is uncertain and we just can't be confident about what to expect. Nate Silver's model looked at the data and said this was one of those situations. I mean, a confident prediction feels more satisfying. We all want definitive answers. But it's better for you to shrug your shoulders than to express confidence without a firm basis to do so. And it's better for the math to do the same thing. Now, the good news is, the great news is that for the business uses of machine learning we're going to cover here, that is the applications of predictive analytics, we make many, many predictions. So lacking certainty and therefore getting a good number of predictions wrong is totally okay, since overall we'll do well enough across many predictions. But I'm actually getting a few videos ahead of myself here. Let's stay focused for the moment on individual one-off predictions, that is, forecasts. So, I feel kind of bad for Nate Silver. He totally got a bad rap. Everyone was like, boy, that Nate Silver's model sure was wrong, but most of the other prominent models at the time actually put Clinton's chances much higher, between 92 and 99%. Those models exhibited overconfidence. Silver's model didn't strongly commit. It expressed, first and foremost, uncertainty. Like when you're a contestant on the TV quiz show Jeopardy, you only buzz in when you think you know the answer to the question, because if you get it wrong, you get penalized. So you gauge your own confidence, your own certainty that the answer you have will turn out to be correct. IBM's Watson computer that competed against the human champions on that TV show did the same thing. Its predictive model served not only to select the answer to a question, it also provided a gauge of confidence in that answer, which directly informed whether or not the computer buzzed in to answer the question at all. So here's my big prognostication. Futurism will be entirely out of style within 20 years. Get it? No, my point is forecasts aren't like futurism. Futurism's the practice of putting your entire reputation down on one confident bet. In contrast, forecasting judiciously allows for uncertainty. It even calls for it as needed. Okay, so the second common election forecast misconception is that the 70% estimates how much of the votes Clinton would get. That's very much not the same thing as the chances of winning. Poll aggregators like Silver forecast the chances a candidate will win. Any forecast they also make about the percentage of voters is secondary and distinct from that main probabilistic forecast. After all, presidential races are much closer than 70-30. 2016 came out more like 46% versus 48%. Now, if the data did have us expecting one candidate would actually get 70% of the votes nationwide, then the chances of them winning would indeed be close to a sure thing, and a landslide victory at that. In that case, maybe they'd actually end up getting less, like 60%, but that's still likely an electoral college win. And the chances are particularly slim that the outcome would land even further away from an expected 70% down to below 50%. So a loss of the election would be a long shot, perhaps only 1% chance. So if you forecasted a candidate will get 70% of the votes, that may very well translate to more like a 99% probability of winning. But that wasn't the deal. The expected proportion of votes is the input to the model, not the output. To be more precise, the model inputs polls, which estimate how many will vote for each candidate, and outputs a forecast, the probability that a given candidate will win. Now, an election poll doesn't constitute magical prognostic technology. It's plainly the act of voters explicitly telling you what they're going to do. It's like a mini election dry run. But there's a craft to aggregating polls, as Silver has mastered so adeptly. His model cleverly weights large numbers of poll results based on how many days or weeks old the poll is, the track record of the pollster, and other factors. So Silver's model turns poll results into a forecasted probability. It maps from one to the other. That's what predictive models do in general. They take the data you have as input and formulaically transform it into a probability of the outcome or behavior you're seeking to foresee. This course is about the use of such models for business problems. Oftentimes, model probabilities come closer to 50% than 100%. They're uncertain. Like when your magic 8-ball says the outlook is hazy. It can be hard to sit with and accept a lack of certainty. When the stakes are high, we'd prefer to feel confident, to know how it's going to turn out. Don't let that impulse draw you to a false narrative. Practice not knowing. Shrug your shoulders more. It's good for you.